So hello everyone, I am Shreyanshu Srivastava and my topic is design of digital filter using least square method. So what is digital filter? It is basically used in signal processing applications to remove unwanted noise or extract specific frequencies. So while designing digital filters, we select some filter specifications such as cutoff frequency, stop band attenuation and filter order. So for designing digital filter, least square method is a popular approach which minimizes the error between the desired and actual filter response. So what is least square method? In this method, we find the best fitting curve for a set of data points by reducing the sum of square of points from the curve. This process is also known as regression analysis. So like this is the set of data points x1, y1, x2, y2, x3, y3 and so on, in which x are independent variables and y are dependent variables. So d is the error. We have calculated like d1 equals to y1 minus fx1, d2 equals to y2 minus fx2 and so on. Then we have calculated error by taking sum of square of all deviations from given values and it should be minimum. So what is the design process? For designing digital filter, first we will determine what is the desired filter response we want, like it could be frequency response or impulse response. Then we will choose the filter order and what is the type of filter which we want to design, like Butterworth, Chebyshev or elliptic. Then we will generate a set of input-output data pairs which will represent the desired filter response. We will be setting some linear equations using the least square approach, and after solving those linear equations, we will obtain the filter coefficients. And using those filter coefficients, we will implement the filter. So what is the objective function here? So the objective function is we need to minimize this function sigma I equals to k to n minus 1 ei square. So what is k here? K is the length of the filter, n is the length of input signal or we can say desired response array, and ei is the error between the desired response and the actual output of the filter. So what are the constraints we have taken? So the first constraint will be that what are the maximum number of iterations for which this LMS algorithm will run. That we will set as max iterations. And then we will take the maximum magnitude of the filter coefficient. We will set it as maximum magnitude. And the next constraint will be the length of the filter, which we will set as filter length. All the filter coefficients should converge to a stable solution and it should not exceed a certain magnitude. So how this LMS algorithm will work? It will continuously update the filter coefficient until the maximum number of iteration is reached or until the filter coefficient converges to a maximum magnitude limit. First, it will calculate the output using this equation. Then it will be calculating the error. And after calculating the error, it will update the filter coefficient. So this is the C++ code. Here we have taken desired response array, input signal, filter length is set to 5, step size we have taken as 0.05, max iterations 1000, max magnitude 1. So this is the LMS algorithm code. Here we have taken all arguments which are constraints. So we have taken 4 for loops. We are using 4 for loops, and after this LMS algorithm we will just simply print the coefficients. So this is the output we are getting for that input. So how this code works? So the first for loop is using for setting the maximum iteration, that this algorithm, this loop will run maximum iteration times. Then in second for loop we will be iterating from filter length -1 to 10. So it will be iterating the input signal array, and for each input sample we are calculating the output. So why we are taking filter length -1 to 10? Because we are ensuring that it is not trying to access those input samples which doesn't exist. Then after this we will be calculating the error. Then in next for loop we are iterating the filter coefficients and we are updating those filter coefficients. Then we are checking the conditions that if filter coefficient is greater than maximum magnitude, then it will be set to maximum magnitude, otherwise it will be set to minus max magnitude. So these are the 4 loops. This is the first loop for maximum iteration, second middle loop, it is for iterating input signal and computing output. This third inner loop, it is for iterating filter coefficient and update them. And this is if else condition. Then this is the second test case we have taken. In this test case, we are taking input signal as a unit impulse and the desired response as a low pass filter. So what the output we are expecting, that it should approximate the low pass filter. So here we can see the result. The coefficients are approximating low pass filter. Then next test case, in next test case we have given input signal as a noisy sine wave and desired response is a band pass filter. What are the output we are expecting, that it will approximate the band pass filter. So here we can see in result that it is giving the desired output. So let's see the next test case. In this we have given input signal as a random noise and desired response is a high pass filter. So what is the expected output? The expected output should approximate the high pass filter. But if we see these coefficients, it is not approximating the high pass filter. So this is a wrong test case. And what is the reason for failure behind it? Because we have given input signal is a random noise and it cannot be filtered to achieve the desired response of a high pass filter. So there are some disadvantages of LMS algorithm, that it has a slow convergence rate, and if we are giving high noise levels, then it requires a large number of iterations to converge to the desired filter. So how we can rectify it? We can use some faster optimization algorithms such as recursive least square algorithm, which has a faster convergence rate. Or another way is that we can use variable step size or adaptive step size algorithm that adjusts the step size based on the error. So these are some advantages, that it is a simple and straightforward approach. It is flexible and it can be used with different type of filters, and it provides an optimal filter response with minimal error. And there are some disadvantages also of least square method, that it is intensive for high order filters and there could be possibility that it may not always provide the desired filter response. So we have seen least square method, which is a popular approach for designing digital filters. It provides an optimal filter response with minimal error. So thank you.